Hello, welcome to my space station. Today let's discuss about the Europa Clipper mission. Now I'm sure you would have heard of it in the news recently. Many people are saying that this is a mission by NASA to search for alien life, and this mission is mainly aimed at exploring the moon of Jupiter called Europa. Now let's delve a bit deeper into this mission. Now, Europa Clipper was launched on 14th October from Launch Complex 39A in Florida, and the mission is expected to reach the moon of Jupiter, which is Europa, in around 2030. So it's a pretty long mission because it has a long trajectory and because Jupiter is pretty far away from Earth. So, what exactly is this mission and why are people so hyped up about it? Well, the first thing about this mission is that this is one of the first missions that we're trying to mainly search for alien life. Like from Earth, we have tried to send signals into space. We have tried to find proof of alien life by checking the composition of different exoplanets. But this is like one of the first missions where we're actually sending a satellite out there to a planet, to like a moon in our own solar system to search for signs of alien, or as I will call it in this video, extraterrestrial life. Now, how can extraterrestrial life even begin in the first place? Well, it needs a few basic components, which is power, basically energy. It needs water and it needs a proper environment, like not too warm and not too cold. It needs proper shielding from the warmth of that the sun is giving it, but also some a bit of coldness to ensure that they don't just burn. So that's how life develops from different proteins and different molecules that form together to form different nucleotides, and that then they form the unicellular organisms, and then they form the multicellular organisms. And after millions and millions of billion years of evolution, and as how they become more complex, then we get intelligent life, the life that is conscious of itself and its existence. This is a very long step, and there is an argument to be made that Earth is the only place in this entire universe where this process was able to occur without any hassles. Now, there is no like certainty to it. Like if you've seen the the Fermi paradox basically states that in this entire vast universe with billions and zillions of planets, so many stars, so many habitable areas where uh, life has the ingredients to grow. Why haven't we found any proof of that? Because see, like even if you think of any very can I say improbable scenario, if there's a large enough sample, then there's a high chance that like that scenario has happened. In cartoons, we've seen people like characters tripping over bananas. This may seem far fetched, but it's possible, very highly possible. In our 8 billion humans, at least one human has died after slipping from a banana. That's a thing. The more like things there are, the more probable it is for a very rare thing to happen. That's how probability works basically. So what we are expecting is that in Europa, now what's so special about Europa? If you've seen a picture of Europa, which should be on the screen right now, you can see that it's like the surface of Europa is pretty like white. It has all these brown lines on it. And to be honest, it doesn't look like it could harbor life. It doesn't have any visible traces of water. It is located pretty far away from the sun, and it is present in the Jupiter's like Jupiter having a big gravitational force and having a huge electromagnetic force makes it so that the sun's radiation is like focused a lot at a few points around like Jupiter, and Europa is unfortunate enough to be located inside that area. So how can life even develop in a such a radioactive area, such a dangerous area? How can life even develop in the first place? Well, that's when we get to Europa as not really like a moon in general. Like we look at it as a world, because Europa is not only the surface. There's also things below the surface. Okay, so the surface that we've seen on top of Europa, the white things, is presumed to be ice. Now, how can we tell that it's ice? Well, we use spectrography, which is basically when we like examine the signals that we're examining, like the light coming from it, like the infrared spectrum, electromagnetic spectrum, like that. And different materials have a different signature of that. And so, if we take a look at it, we can try to match the signals that we're getting from that like area to match the things that we already have on Earth. So the thing is of that electromagnetic spectrum of that actually matches towards frozen water. And regarding the brown lines that we see, well, since Europa is like pretty small compared to Jupiter, and that Jupiter's gravitational force is pretty strong. This like creates a sort of effect that Europa is not always a sphere, because Europa's orbit is like, if here's Jupiter, then the orbit is closer at one point and farther away at one point. This creates a small like effect that when Europa is closer to Jupiter, it becomes more squished on its sides. And when it's like not that much, like if you want to turn it into an oval, but there is enough, like around 30 meters, which is a lot. It becomes like a bit oval shaped, and then when it's far away, it regains its spherical thing. So after years and years of this happening, the squishing and the unsquishing, the squishing and the unsquishing, this creates for some signs of that on the surface. And why is it brown? Now here is we get to another proof that Europa might have water. Now we have performed experiments on Earth where we put water through a lot of radiation, and we like try to simulate what water would be like if it was on Europa's surface. And we have actually proved that the water actually does retain a kind of brownish impact on the surface, which kind of does match what we are seeing on Europa. So that's another big proof of water. Now let's get back to the mission. How is Europa Clipper going to prove that? Now, because it's not a lander, it's not going to land on the surface. It's kind of it's gonna observe it from afar. Now, the trajectory of it is pretty interesting because it will leave Earth. It has left Earth. It will go into an orbit around like Mars. It will get a gravitational assist and go back to Earth. Get another assist from Earth. Go back to Mars. Get a final assist from Mars, and then be like slingshotted out towards Jupiter. Around 2029 and 2030, it will like near Jupiter enough that we can get the first data. We can get the first data, and eventually it will move into not an orbit around Europa, but an orbit about Jupiter, because of the same issue I mentioned. See, there's so much radiation around that area that none of our technologies can survive, that they will be fried. Okay, this was also an issue on board Juno. There was a mission launched by NASA long ago, which was Juno. Its main like mission was to explore the moons of Jupiter, not one moon specifically, generally all the moons. The issue was that a bit of the radiation actually corrupted one single bit. This is a true story. They corrupted one single bit, and the Juno space probe had to go into safe mode. And later on, they deemed that it was not useful. And so, to maintain to preserve Jupiter, like if like let's say like we just left it there, then it would actually be in an orbit around Jupiter forever, and that could be an issue for future missions or could contaminate the environment. So they just crashed into Jupiter entirely. This was all due to radiation. Now we are coming to it better prepared. Now we don't want to leave our clipper there in that radioactive area for too long, else it would also go through a similar issue, because we haven't found a good way to prevent the radiation from harming it. Yes, we can delay, but eventually something will go wrong because the radiation there is very immense. So that's why we're not going to be in an orbit around Europa, but in orbit around Jupiter. So like we'll have flybys, right? That's kind of how the Parker Solar Probe mission went. It didn't go in front of the sun, like it didn't just orbit the sun. It would be fried to a crisp. It had flybys. It came in close proximity, then went afar to recover. Close proximity and then went afar. Kind of the same thing that Clipper is doing. Now, why is it called Clipper? This comes down to how it is going to search for water. Now, if we're going to search for water by using those previous measurements that I told in the first place, then why even send a space probe there in the first place? The thing is that we're going to use something called like, see, Europa has a thing on the surface where tiny jet streams. Like we have observed from Earth that jets sprout up, right? Which we think they are water or some other some other chemical compound. We know that there is some liquid which is sprouting out from the surface of Europa, and the mission is basically trying to capture that. Now there is an example which I could like help you understand. uh, Sometimes when we need to determine if a whale is in good health condition or not, sometimes we send thingies into the water, send like submarines kind of into the water, and they like, you can't perform surgery on a whale. What you do is that you take the snot, or basically the that comes out from the whale's blowhole. We don't go inside the whale, we just check the chemical composition of like the thingies coming out of the whale's blowhole, and then like we can determine like how the whale is feeling and all that, like generally if it's medically okay or not, if there are any viruses there or anything. Kind of the same thing we're gonna do on Europa. The Clipper mission on its flybys will perfectly align to fit any of the jet like streams that we come, like it'll be watching for them, As soon as we get them in a flyby, it's going to try to get the it's going to try to fly over it at a very low altitude, and it will try to collect a bit of the like liquid that we're coming in, and then it's going to fly out. And then, like, because it can't analyze it, like because it's trying to escape the area, it's going to fly out, and then it's going to analyze it, and then it will send the findings back to Earth. So this could mean that if we discover some interesting compounds, like if we find traces of water, if we find some carbon, if we find some methane, anything like that which could hint towards there actually being water under the surface, then we would be assured that there is a possibility, there is a high possibility of life. Because life doesn't only mean us or tigers or lions. Life could be unicellular, could be multicellular, but on the atomic scale, like on very, very small scale, on the atomic scale, very small scales. Even that scale is like good enough. Like if we do find evidence of uh, bacterial life on Europa, then that could mean that the Fermi paradox is true, and then there is life everywhere. There is 100% guaranteed life everywhere, but we haven't found it yet. Because evolution happens slowly and slowly and slowly. Take a million years. A million years is nothing. In a million years, you can't even advance from the unicellular stage. So life needs lots of time to like life needs lots of time to advance into intelligent beings and people that like beings that have control over the planet and that can control like their planet also. So this is like one of the big aims of the Europa Clipper mission, and the reason it's called Clipper, which was I was going to tell you, because like long ago during the times of ships, people during the times of battle, they'd be these small ships that would go in, attack, and quickly move out. Or if they had to loot something, they'd loot something from a base and quickly run out. Like they do this in a cycle. So like they don't spend too much time in the ports or whatever. And that's the kind of strategy. They were called clippers, and now that's why we're calling the Europa Clipper, because it's gonna perform close flybys and try to get that liquid that's coming out of the surface. So why Europa only? Now this is a big question, which like obviously why are you looking for life on a place where there's lots of radiation, where you're not even 100% certain there's water on the surface, because there are moons of Saturn. There's a moon of Saturn which we're 100% certain that there is water in there. Why are we searching there for Europa? Because we are also sure about one thing more, is that Europa developed very long ago, and the moon of Saturn, which we have confirmed, I'll put the name of there, which there is water under there. We're not sure if it's that old, and obviously life needs a lot of time. So if our measurements are accurate, and the approximated like ages of the moons are like correct, then that means that there's a higher chance, if there's water there in Europa, there's a higher chance for us to find life there instead of the moon of Saturn, because life hasn't properly evolved there yet. So this mission is still under progress, and as of the time when I'm recording this right now, there is still 5 to 6 years ago before we start seeing the first results of the Europa Clipper mission. And it's for us to hope that everything goes okay, nothing wrong happens, the radiation doesn't do something like it did to Juno. And once there are some more updates regarding this, maybe in 5 years or something, if I'm still around, I'll definitely give you some more information on that. Now it's just a matter of waiting. So I hope you learned a bit about the Europa Clipper mission, and I hope you all have your hopes high for what it can achieve and for what it will tell humanity about the nature of the universe. Thank you.